Hi, this video is going to discuss what end behavior is. So end behavior is a way to describe what happens to the function as x approaches positive and negative infinity without having to draw the graph. What that means is we can express with notation what's happening on the left and the right side of this graph. So you have to know which way you're looking, whether you're looking left or right. As x goes to negative infinity, this piece right here, x values go left to right, and negative x values are on the left. So when it says as x goes to negative infinity, it's saying what's happening on the left side of the graph. Looks like my pencil is not working. And on the left side of the graph, the function is doing what? Well, the function is heading downwards. It's heading downwards towards negative y values, which indicates it's heading down towards negative infinity. So to write with notation, left and down, we say as x goes to negative infinity, f of x goes to negative infinity as well. As x goes to infinity, x values go left to right. Positive infinity is on the right-hand side. So this is saying as you go to the right, what is the function doing? The function on the right side of the graph is pointing upwards. So to indicate you're going upwards towards positive y values, you put positive infinity for up. It's really important that you memorize the setup for end behavior because you might be asked to express it on your own. Now, end behavior with logarithmic functions and exponential functions can sometimes be tricky due to the asymptotes. So we're going to figure out the end behavior of first an exponential equation, f of x equals 3 to the x minus 2. And if you don't know what the graph looks like, what you can do is you could put this in the calculator. I have my calculator with 3 to the x minus 2, and you're going to look at the graph. And the graph does look like it flattens out because of that horizontal asymptote. And we're going to make a sketch of it. And it's really important to figure out where this graph flattens out. So it's kind of hard to see it looking at the graph, but you can go to the table. And if you look at the table, you're going to see as you go towards negative infinity, the numbers start to just be -2. And if you look, you're not actually hitting -2. It's just that you're getting so close to -2, the calculator says, well, you might as well be at it. But this does tell you what your asymptote is. Remember, you don't actually touch the asymptote. It's just that we're getting super duper close. You'll see -1.99999999. You're so close to -2, the calculator tells you that. So now you know that this asymptote that you are approaching is at -2, specifically at y equals -2. And once you have an idea of what the graph looks like, then you can express your end behavior. So as x goes to, we'll go with negative infinity first. It doesn't matter which one you do. This is saying as you look to the, as x goes to negative infinity, x is left to right. As you look on the left towards negative infinity, what is this arrow doing? Well, the function is approaching the asymptote. Remember that you get super close to the asymptote, but you never touch it. So while the graph is going down, you will not go past the asymptote. You're not going down towards negative infinity. You're flattening out at -2. So the graph is approaching -2. And then you have the other direction. As x goes to positive infinity, this is going to be positive x values. This is going to be on the right. And on the right-hand side, the arrow is pointing upwards. Well, we know that if you're going upwards, f of x, the function, goes to infinity. So this is saying left, it's going to -2 towards the asymptote, and to the right, it's going upwards to infinity. And we're going to try it again, this time with exponential functions, actually logarithmic functions. So we're going to put the log in the calculator and see what's happening. I have the function log base 2 of x minus 4. I'm going to go to the graph, and I see, remember, your calculator doesn't graph logs properly. I can see that there's an asymptote. Maybe you could see that the asymptote is at 4. However, if you go to the table, you'll be able to identify that it is definitely at 4 because your asymptote is where the first error is right before the number. So our asymptote is at 4, which means you would go 1, 2, 3, let's put 4 here. This is x equals 4, and then the graph of the logarithm looks like that. Now that you have the graph, you can identify the end behavior. As x goes to negative infinity, what is the function doing? So negative infinity, actually can't even put as x goes to negative infinity because it's not going towards negative infinity. That asymptote makes you stop at 4. So as x goes to 4, what is the function doing? Well, as x goes to 4, the function is heading downwards. So you would say that the function f of x is going down towards negative infinity. And then as x goes to positive infinity, which means positive x values, here's 4, here's infinity. So as x goes to the right, what is the function doing? Well, on the right side of this graph, the function has an arrow, and the function is going upwards. It's just that logarithms go up very, very slowly. But to indicate that you are going up, you put a positive infinity. Anyway, I hope this helps. Now you could try 2 questions on your own.